Today we are going to solve Cambridge O level paper, May June 2022, paper 4, variant 1. Question number 1. A student investigates how the temperature of a volume of water changes as hotter water is added to it. 160 centimeter cube of water at 20 degrees centigrade is poured into a glass measuring cylinder. Figure 1.1 show the measuring cylinder. The measuring cylinder contains 160 centimeter cube of water. On figure 1.1, draw the level of the water showing the meniscus. Water level is not horizontal like this. It is little bit higher from the edges, something like this. So we called it as meniscus. For water, the sides are higher, but for the mercury, the sides are lower. So it is the bending of the your water at the boundary. It is called as meniscus. Now the water is 160 centimeter cube. So 160 centimeter cube will be between 150 and 175. So 175 minus 150 will be equal to 25. And total 10 lines are dividing it. So divided by 10. So one line is representing 2.5. So for this 160 will be the fourth line. 150 will be the fourth line. 152.5, 155, 157.5 and last one 160. So we are going to draw meniscus like on the fourth line, a horizontal line at the center and curve at the edges. It will be our meniscus. Part B. The student pours 100 centimeter cube of water from the measuring cylinder into a large beaker. He then uses a kettle to provide a constant supply of hot water. Add 50 centimeter cube of hot water at 70 degrees centigrade to the beaker. Stir the mixture. Record the new temperature of the water in the beaker. Continue to add 50 centimeter cube of hot water at a time, recording the new temperature for each addition until a total of 300 centimeter cube of hot water has been added. The student ensured that the temperature of the water added each time is 70 degrees centigrade. So just how this is done. Check the temperature before adding. If it is less than 70 degrees centigrade, then heat the kettle to maintain temperature of 70 degree centigrade. The student repeat the experiment and obtain 3 sets of results as shown in table 1.1. Total volume of the hot water added V by centimeter cube. Temperature will be represented by theta degree centigrade and the average temperature is theta average degree centigrade. Calculate the average temperature when the total volume of hot water V is 150 centimeter cube. Record in table 1.1 answer to an approximate number of significant figure. Now we have to calculate the average of these three values: 47 plus 49 plus 46 divided by 3. It will be equal to 47.3. And all our answers are in two significant figures, so we will write it as 47. On figure 1.2, plot a graph theta AV degree centigrade on y-axis against V centimeter cube on x-axis. Start both axes from the origin 0, 0. Draw a smooth curve to fit best fit. Okay. First of all, we are going to represent our axis, and at y-axis we have average theta average and it is degree centigrade, and for x-axis we have volume and it is in centimeter cube. So our theta average is from 20 to 54. So we have to divide our graph between 0 to 54 on y-axis. So I am dividing it 10, 20, 1, 2, 3, 30, 40, 50, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 60. And for the volume, we have the values between 0 to 300. So it will be divided as 50, 100, 150, 200, and 1, 2, 3, 4, 5, 250, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 300. Okay. On the graph paper, the lines are more dark after every 10 blocks, but here it is not very well accurately seen. So for the 0 the temperature is 20, and for 50 the temperature is 33. For 0 temperature is 20, and for 50 temperature is 33. So 30, 1, 2 and 3, it will be over here. And for 100 the temperature is 41, and 150 47, 41 and 47. So 41, and for 150 it will be 47. So 41, 50 line, okay, 41, 2, 3, 4, 5, 6, and it will be here 47. Now for the 53 and 51, 53 and 54, 51, 53 and 54, 51, 53 and 54, 51, 53 and 54. Now we are going to draw a curve which will be best fit for our graph. So it will be like a curve like this one. It is the best fit curve. Your graph show that theta AV is not directly proportional to V. Describe how your graph showed this and suggest why theta AV is not directly proportional to V. If the two quantities are proportional to each other, then the line will be a straight line. So no straight line, it means that they are not directly proportional to each other. Not a straight line. So not directly proportional to each other. Proportional to each other. Now, describe how your graph show that this and suggest why theta AB is not directly proportional. Because some heat is lost in the surrounding. Some heat is going to lost in the surrounding. Our beaker will lose some heat in the surrounding. Okay, the student repeat the experiment with a thin layer of insulation around the beaker. On your graph in figure 1.2, sketch a line to show the results with a layer of insulation around the beaker. So label this line with letter A. Now we have now insulation. So insulation means there will be less heat loss to the surrounding. So our graph will be like something a little bit higher than this. And we are going to represent it with A. Our graph will be something higher because less heat loss, so every time the temperature will be a little higher than the previous one. Question 2. A student investigates the resistance of two resistors. Figure 2.1 show the apparatus used to find the current I in the resistor X and the potential difference V across it. Draw a circuit diagram for the arrangement shown in figure 2.1. So we start with the battery. We have battery in the start, then it is connected to the switch. The switch is connected with the resistor named as X, and it is connected with the ammeter. So ammeter and ammeter is connected with the battery, and there is another parallel line for the voltmeter. So voltmeter is connected parallel with the battery. So we have a switch, a voltmeter connected parallel to the battery, and ammeter and the resistor X. The student record the current I and the potential difference V across the resistor X when the switch is closed. He calculates the resistance Rx of resistor X. He replaces resistor X with now resistor Y. The value recorded for both resistors are shown in table 2.1. X 0.1, voltage will be 1 and resistance will be 10 ohm. Y 0.07, current V voltage is equal to 1.0, resistance is not given. Calculate the resistance Ry of resistor Y and complete table 2.1. Use the equation distance equal to V over I. Give your answer to the nearest whole number. So we know that the value of V is 1 and the value of I is 0.07. From these two, voltage will be 1 volt and current will be 0.07. So our resistance will become 14.3, but because we have to give the nearest whole number, so we are going to write it as 14. The student combined resistor X and Y in parallel arrangement. He uses this combination in the circuit in figure 2.1 in place of the single resistor Y. Figure 2.2 shows the ammeter reading for the parallel arrangement. Record the reading I shown in figure 2.2. So from 0 to 0.2 it will be 0.2 and the reading is till the 8th line, so multiply by 8 and divided by total lines are 10. Total portions are 10, so 0.2 multiplied by 8 divided by 10, which will be equal to 0.16. 0.16, or you can do it like 0.2 divided by 10 will be equal to 0.02 and added 0.028 times will also be 0.16, or you can use this formula 0.2 multiplied by the line which is which type the arrow, or divided by total number of lines from 0 to 0.2. These are 10 lines, so 0.2 multiplied by 8 divided by 10 will be 0.16. The potential difference stay at 1 volt. The potential difference stay at 1 volt using the value of I in B2, and I in B2 is 0.16, 0.16, and the equation in B1. B1 is R is equal to V over I. V over I. V divided by I. Calculate the value of RC. So RC will become 1, which is voltage, 1 volt, divided by current will be 0.16, and your RC will be equal to 5 point, no, 6.25, 6.25 ohm. Theory suggests that the RC of the two resistors X and Y arranged in parallel is given by RC is equal to RX RY divided by RX plus RY. State giving a reason whether your RC in B2 agrees with the suggestion. Now we are going to calculate the value of RC, where RX is equal to 10 and RY is equal to 14 divided by 10 plus 14. What is Rx and Ry? Uh, these are the values of Rx and Ry, and it will be equal to 5.83. 5.83. Now we are going to find the percentage error. We are going to subtract 6.25 minus 5.83, and it will be equal to 0.42. Now the percentage error will be 0.42 divided by 6.25 multiplied by 100, and it will be equal to 6.7%. So our error is less than 10%. So we agree with the suggestion. As error percentage is less than 10%, so we agree with suggestion. Question number 3. A student directs two parallel rays of light, ray 1 and ray 2, toward the side of a transparent plastic block as shown in figure 3.1. The block rests on a sheet of paper. Okay. The student marked 2 points R and S on the path of ray 1 after it passed through the block. On figure 3.1, draw a line joining R and S and continue to meet the block. Now we are going to draw a straight line between RS, which will be continue to join with our lens or the plastic. It will be like this, a straight line. A little bit more straighter. It will be like this, a straight line. On figure 3.1, draw a line to complete the path of ray 1 through the block. So in block, it will be like this one over here. On figure, the student marked 2 points W and X of on the path of ray 2 after it passed between the lines of the block. The student marks 2 points W and X on the path of ray 2 after it passed through the block. On figure 3.1, complete the path of ray 2. So same procedure, W and X, and it will be like something this. Extend the line SR and WX back until they meet at a point. Label this point F. So when you are doing like this, it will be somewhere like over here, and this is known as the focal point. Now the now measure the perpendicular distance from F to the center of the block. Now you have to measure the distance between this and the center line, and it will be approximately equal to 2 centimeter or 2.1 or 2.2 centimeter. It will be equal to 2.1 to 2.2 centimeter. Question number 4. A student determine the diameter of a thin wire. The apparatus available is 2 meter long of 2 meter length of thin wire. A wire cutter ruler suggests how the student determine an accurate value for the diameter of the wire using only the apparatus listed. Draw a diagram to illustrate your method. First of all, we are going to cut our wire into 5 to 10 pieces and place them like this. Then place the meter rule below them and calculate the distance total length of the cut wire, and then divide our value by the total number of wires which we have cut and placed horizontally. Cut the wires and place horizontally on the table and measure the total width of the wires with ruler and divide it with number of pieces. If you have 5 pieces, then divide it by 5. If you have 10 pieces, divide it with 10. If you have 6 pieces, divide it with 6. A second student determined the diameter using the different piece of operators. His value for the diameter is more accurate. State the name of the different pieces of operator he used. Different piece of operators must be screw gauge. Screw gauge. Because screw gauge can find the more accurate result for the diameter of a thin wire.